Welcome back to part 2 of how to make your own plugin. To pick up where we left off, we had just got our local working copy repository up and ready to go and everything renamed so that we can start writing some code to actually make a functional mock occupancy detector. In this video, part 2, we'll discuss how to derive from Essentials device, factory classes like the Essentials plugin factory, and methods like build device, and how to set up a configuration file and load your plugin. So now we have our clean repository, which contains a solution for an Essentials plugin. Now, basically, this is a simple Sharp library, simple Sharp Pro library, I should say. So let's start off. We're going to open the mock occupancy detector device class that we renamed earlier. And we're going to talk about how to extend the class Essentials device. Essentials device is constructed inside the framework. It exists basically to add a lot of the functionality like the activation logic and take care of a lot of the activation steps of devices for you. So your best bet is to derive from Essentials device wherever possible. Almost all of our device classes derive from Essentials device or one of the extensions of it. So here we have this class called mock occupancy detector device, which derives from Essentials device and implements an interface called iBridge Advanced. We'll get into that later, but this interface basically allows us to bridge across a simple window or across to simple Windows program using an Ethernet intersystem symbol. So the purpose here in this little example plugin that we're building is, let's say one of the challenges you have is you need some logic to happen in a room based on whether or not an occupancy sensor detects, presence or occupancy or vacancy in the room. That's usually a pain in the butt to test in the real world because even if you can put it in test mode, triggering your logic off of an actual physical sensor is a real pain. So maybe we want a mock device that we can dump into our program and we can use console commands to set the state to occupied or vacant and test our logic that's based off of how we want that occupancy sensor state to exist at the time. So in the framework already, we already have real Crestron occupancy sensor classes, and we have some of the devices like the Cisco Spark codec can indicate whether a room's occupied or not by using its internal camera. So we have created an interface called iOccupancy Status Provider, and this tells us basically all the things we need for this class to behave like a device that provides occupancy status to something else, like say a room. So here I'm going to implement this interface and I'm going to scroll down, and it's just dumped this region in here that includes all of the stuff that's required in this interface. And what you'll note is that the only thing that's required is a property of type bool feedback called room is occupied feedback. Now, bool feedback is a class we've created to make your life easier when you're interfacing with Crestron SIG classes. So a SIG is something that represents a signal on a try list, and a try list is something like a touch panel or a remote or an Ethernet intersystem symbol. So basically, we've built this class that contains a bunch of logic to make your life simpler when interfacing with Crestron hardware. And I'm going to just copy and paste this to the top of the class to make it a little easier to see. And by default, it adds a getter that throws a system.not implemented exception, but I'm just going to change this to get private set. And we'll get into how this feedback works here, but there will be a dedicated video in the future about how our concept of feedback classes work. All you really need to know for now is that there are different types of feedback classes, and they reside in the pepperdash.essentials.core namespace. There's a bool feedback, an int feedback, and a string feedback, and that's really what you need to know for now. So how would we make this device behave as though it were a real occupancy sensor? Well, let's add a couple of methods that we can trigger from console commands. We're not going to make these public. You know what? Actually, we will. We'll make these public because that will allow us to trigger them from the generic console commands as well, but we're going to add explicit console commands here to trigger them. Set occupancy status let's say call it occupied status. And we'll pass in a Boolean to represent the state. And in this case, I'm gonna add a little private backing variable here. And what we're gonna do is we're gonna use this value, and whenever we set this value, actually instead of a field, we're gonna make it a property. Get, and then I've been doing too much JavaScript lately. And then add our setter. Oh boy, I am definitely in JavaScript mode. All right, and let's actually make that a private property, and then in the background we will add a real backer variable here. And basically what we're going to do here is we're going to return the value of our backer variable, and then in the setter we're going to do something different here. In the setter we're going to say if the incoming value equals the backer, does not equal the backer value, we are going to set the value of isOccupied to the incoming value, and then most importantly, what we're going to do is we're going to call room isOccupied feedback dot fire update. So what this method does is it basically triggers this feedback and anything that's subscribing to it and linked to it to update the corresponding value. And we'll get into the mechanism that does that shortly. You know what, actually, I'm gonna make this public so that somebody could view the current state at any given time, in which case we're going to capitalize that there. So basically what we want to do here is we want to set isOccupied to the state value. And that's all we really need to do, because by setting the value of isOccupied, that calls our setter. It checks if the value is different than the previous value, and if it is different than the previous value, sets the backer variable to the new value, and then fires the update on this feedback class. That basically takes care of that. Now what we're going to do here in the constructor is I'm going to do Crestron console. Oop, don't have the right using Crestron.simplesharp Pro, I believe. And then I'm going to do Crestron. I have no idea what namespace that's in. Crestron.simplesharp. Yep, there it is. So it's in SimpleSharp. Add new console command. And in this case, I believe it needs to take an object. No, it'll be a string. And then we're going to call set occupied status. All right, so there's the user function, and then we're going to give this a name. Whoops, which is set occupied state, and then a little help, sets the state of the mock occupancy detector. And then our access level, I generally will set this to operator. And just to make this a little more readable for everyone, I'm going to pop that down a line. And it doesn't like the format of my Lambda here because, oh right, it wants a string. There we go. Okay, so now what we're going to do is we're going to check if state equals true. Var s, or say bool s, and if state equals true, then s equals true, else if, we're going to explicitly check this, false, then s equals false. And then I'm going to say else return, just so that we don't blow up if our value doesn't match. So basically what we're doing here is somebody's going to call this console command, and they're going to, you know what, I'm going to add some additional help text here. Now, be very careful of the length of your help text message. If it exceeds some arbitrary number of characters, it's like 81 characters, your program will accept and crash on boot, and it won't tell you why. Basically, it'll crash at the point when this console command is added, and there's no error log warning, there's no nothing. It just drives me nuts all the time. I can never figure out why it does that, and then I remember, oh shoot, I just added a console command, and it is fairly long help. So just be mindful of that. Try not to make it too long. So basically what's happening here is when somebody calls this console command followed by either true or false, we are going to call this method, which is going to check and see if the text they passed in is either true or false. And if it is true or false, it's going to set the value. Otherwise, it's going to return and do nothing. And it's going to set the value of is occupied, which is going to take care of firing our feedback. Now, what we need to do is we need to define this feedback in the beginning. So in the constructor here, we need to construct this feedback. So this is a new bool feedback, and what a bool feedback wants is it wants a func, which is a construct in .NET that you can look up here. If you look, it wants a func of type bool. So it wants a func that's going to return a bool. And in this case, we're going to return the value of our internal backer variable. So what actually happens with these feedbacks, and again, we'll get into this in more detail in the future, but for our purposes now, what you need to know is that when you construct a feedback, you feed in the func, and the feedback actually computes its value at the time fire update is called. So all that's going to happen here is the user, you in this case, is going to call this console command, set occupied state, and pass in true or false. It's going to call this method, check the value that was passed in, and set the value of this, which is in turn going to trigger this chain of logic to fire this update, and then something downstream is going to subscribe to this state of this mock detector and respond accordingly. And it can do that either by subscribing to the output change event on this bool feedback instance, or we can link this to, say, a digital signal on an EISC or a digital signal on a touch panel or something of the like. Something that has a Crestron SIG class instance on it. So I'm just going to save that and compile it and make sure it compiles clean. Hopefully we will get no errors here. And there we go. So compiled clean. And next up, we'll show you how to build the factory class so that you can actually instantiate an instance of mock occupancy detector device from your configuration in a running Essentials program. All right, so let's talk about how we would actually construct an instance of one of these devices. So I'm going to open up this mock occupancy detector factory class, and basically, this is the thing that Essentials interfaces with when it's trying to instantiate one of your devices in your plugin. We look for this when we load your plugin. We basically use reflection to iterate through the types in your plugin, and we're looking for something that derives from Essentials plugin device factory. And then it's going to pass in its own type so that we know the type of the plugin device factory. So there's a couple of important things to know here. The first one is this property, this minimum essentials framework version. This is here so that you can tell the Essentials program what the minimum version needs to be to support this plugin. So by default, we have this set to version 1.6.1. We generally update this to the latest version of Essentials so that when you're writing against a version of Essentials, you want to usually specify that version as the minimum version for your plugin, because you know it'll work with this version. You don't know for sure that it will work with previous versions. You might try and reference an interface or some part of the framework that doesn't exist in an earlier version of Essentials. The second most important thing, or arguably the more important thing, is this type names list. So type names is a list of type string that exists on this instance of the factory. And this is what tells us what kind of device you want to build. So what we want to do here is occupancy detector. So this is the value in our configuration file. When you look in the devices array, you'll see a type property for each device. This should be the value of the type property to instantiate one of these devices. And this gets added when we look in your plugin and we find an instance of Essentials plugin device factory. We go read out the type names values. So you can have more than one value here that will create an instance of the same device. So you could have mock occupancy detector, you could have mock OD, mock occupancy sensor, all the variations of text that you want to instantiate an instance of this device. Where that's really handy is if you have a class that can represent a bunch of different things. Say you have a class for DM transmitters and you have one base class that handles a bunch of different kinds of DM transmitter, you could list out all of the different model numbers of DM transmitters here, and they would all create an instance of the same device, but maybe they pass in different configuration information that handles how to set up that particular instance of that DM transmitter to, deal with the difference between a DMTX201 and say, a DMTX 4K302C or whatever the new version is. So I've got our type name set, and then what will happen when the configuration gets loaded and we find an instance in the devices array of the configuration that has a value for the type property of mock occupancy detector, is we will have already pre-registered this method as saying, call this method and pass in that configuration object of that device into this method, and we'll build you one of these. So what's going to happen here is we're going to pass in the device config after having deserialized it into this type. So if we open up this mock occupancy detector config object class, this is what would allow us to define the properties of this device. Now here we just have some example stuff. We've got a example string, my device property, and we've got an example control block. I'm not going to have any properties for this device. We're going to keep it simple, but here's where you would define your properties. There's lots of examples in the Essentials framework and in our example plugins of how you do this, but I won't get into it here. For all intents and purposes here, this first line isn't really going to do anything. It's going to grab the properties object of the device's configuration, and it's going to try and deserialize it, but it's not going to have any real information in it. But more importantly, it's going to call the constructor of the mock occupancy detector device class, and it's going to pass in the key from the config, the name from the config, and the configuration itself. It's going to return that as new device, and then we return new device back to Essentials, which is calling the build device method. You probably don't need to do a whole lot with this other than what I would recommend in some cases. If you are building a device that requires a communication class to be constructed, so say your device needs to speak SSH and it needs to build an SSH client, or maybe it needs to speak TCP and it needs to build a TCP client. It's not bad practice to construct the instance of the communication class first before trying to construct the actual device, because if something about the configuration fails the ability to construct the communication class and you can't communicate with the device, then there's no point in building the device. But that's up to you. Again, you can see lots of examples of this in the Essentials framework. But in this case, it's a mock device. There's no communication method. We're going to keep this really simple. But this is basically how the factory gets dealt with. And this will take care of building an instance of this device when we have configuration that has a type name that matches mock occupancy detector. Next up, I will show you how to modify a configuration file to tell the config to build one of these instances, and how to load this up to Essentials and test it. Okay, so now we have our plugin built and it's time to load and test it. So I've created a folder called config example in my plugin repo here, and I've taken one of the example configuration files from the Essentials framework repository. In this case, it's for a simple huddle room with a single display and a fake video conference codec. And I've opened up that file in Visual Studio Code here, this configuration file. And the only thing I'm going to change is there's already an occupancy sensor in this system. It's looking for a Crestron occupancy sensor. But let's say the real world application is, I need to test this room, and for some reason, this occupancy sensor isn't installed in the ceiling yet. But I need to test that my logic works. So what I'm going to do is I'm going to go to here, and just to make sure, I'm going to copy this value. This is my type name that we're looking for. I'm going to copy that, and I'm going to paste it into my configuration here as the type property. That's the only thing I'm going to change. This way I can swap that back later and be in good shape. I'm going to save this. I'm going to open up FileZilla, which is my preferred FTP client. I'm going to take the file that we just changed. I'm going to drop it into the Program 1 user folder here, which is where my configuration file belongs. Then what I'm going to do is I'm going to make sure I've got the right version of Essentials loaded. So inside my repository here, I have an Essentials builds folder, which contains the version of Essentials that my submodule is pointing to right now. And I'm going to drag that into the Program 1 folder. And then lastly, inside our solution here, I'm going to open up the binary folder, and inside the debug folder, I'm going to find my CPLZ that we built when we compiled the plugin. And I'm going to drag that to the plugins folder, which is inside my user/program1 folder. So what's going to happen here is we are going to load this program, and it is going to load version 1.6.1 of Essentials. Then it's going to try and load our plugin. And once it's loaded our plugin, it is then going to try and load the configuration, which now has an instance of an occupancy sensor device in it that's going to try and load the mock occupancy detector device from our plugin. So we'll wait a few seconds here while it loads up. If I were smart, I would have used my MC4 for this because it loads faster, but the good old RMC3, there's nothing wrong with that. So basically, once this loads up, we're going to double check some of the console messages just to make sure that it looks like everything's going correctly when the program loads. And we can see here it started version 1.6.1. It's telling us built-in types or factory methods it has for these types. We should see a message here shortly. There we go. It's loading our CPLZ file. And once it loads that, it's going to load the configuration file. And when it's all done here, there we go. So the program's loaded, and the first thing we're going to do is run help user. So help user tells us all of the custom configuration or the custom console commands that have been added. And sure enough, there's our set occupied state. So what I'm going to do is, just to make sure I don't mistype this, I'm going to copy that and I'm going to paste it down here. And then I'm going to add true. So what we're going to do is we're going to call this console command and pass in the string true. And what do you know? We get a console debug message from our device with the key of GLS ODT CCN1. And if you remember correctly, when we look at our config, we didn't change the key. So it still has the same key. So that's the device saying that we just set the mock occupancy detector state to true. And we're also seeing a notice from the room, which is linked to this occupancy sensor, that the room thinks it's occupied now. So let's go back and change this command, and we'll run set occupied state to false. And looky there. The occupancy sensor mock class says that its state is false. The room says that vacancy has been detected and it started its vacancy timer. So this is a real world example of a simple little plugin that allowed us to create a mock device to mimic the behavior of a real device where that real device might not be actually physically accessible or ready to go when we're on site trying to do something. So yeah, this is kind of a simple example of how you can build your own plugin. Obviously, the sky is the limit in terms of the functionality inside the plugin. You can make it as simple or as complicated as you want. But thanks for following along. Well, that was a long one, so thanks for sticking around and watching the whole thing. I really, really encourage you to go back and follow along with the video and write your own plugin and try and test it, even if you just write the same plugin and get to see the console statements work for you in real time. It gives you a real sense of satisfaction and accomplishment. As always, when you're following along, if you run into anything and you need to ask some questions, please come join us on the Essentials Discord server. We'd love to help answer any questions or any hurdles you run into. And as always, if you have any other questions or you want to become a participant in the community there, we'd really appreciate that, and we'd love to see you there. So thanks again for watching. Don't forget to like and subscribe. Yada, yada, yada. We'll see you next time.